In this video, I want to give an answer to this very important question because we have spent a lot of time describing both node voltage method and the mesh current method, and for each one of them we went through some special cases too. And the whole point was to be able to solve a circuit with fewer number of linear equations. So now the question becomes, which one is better? So both of these techniques are great tools for reducing the number of simultaneous equations. But again, which one is more preferred? So to answer this question, we need to find the answer to some additional questions, because there is no one answer that can be applied to all the circuits. So depending on the circuit that we are working on, there are a few questions that are raised that if we can find the answer to those additional questions, we can see which one of these techniques is better. So the first one is that for the circuit in question, for the circuit that we want to solve, which one of these two techniques results in fewer number of simultaneous equations? So coming up with the number of equations that each one of these techniques gives us is very straightforward. So for example, for the node voltage method, we had to find the total number of essential nodes, and the number of equations that we needed to write was the total number of essential nodes minus 1. So if you have a circuit that has 4 essential nodes, since one of them you consider it as the reference, so you only need to solve 3 equations. For the mesh current method, you count the number of meshes in your circuit. So the number of equations that you need to solve is equal to the number of meshes that you have in your circuit. So that was the basic question that we needed to ask ourselves. So the follow-up questions are, do we have any supernodes in the circuit? If we have any supernode in the circuit, that means that it is possible that the node voltage method results in fewer number of equations, right? Because we said that if we have supernode in our circuit, we can combine the nodes that have a voltage source between them and use them as a supernode, and that reduces the number of equations. The same is true for the mesh current method too. So for the mesh current method, if we have any super mesh, basically if we have current sources that are shared between 2 meshes, we can consider them as a super mesh, and that helps us reduce the number of equations that we need to write and solve. And the final question, and sometimes the most important question, is that what is that we are asked to do? So do we need to solve the whole circuit in order to find the thing that the question is asking us, or no? So in another word, does solving a portion of the circuit give the requested solution? If so, which one is more efficient for solving the needed portion, right? So that is another important decision or important question that we need to answer. So let's just take a look at a couple of examples. For these 2 examples, we assume that we want to solve the full circuit. So let's just take a look at this circuit and see which one of the 2 techniques is better for us. So first of all, for this circuit, let's just go and count the number of essential nodes that we have. So there is a node here, but it's not an essential node, so I don't count this. This one is an essential node because it's the point of contact of 4 elements. This one is another essential node. It's a point of contact of 3 elements. This one is another essential node, which is the point of contact of 4 elements. And finally, this one, or like any of these two, is an essential node, which is the point of contact of 5 elements. This voltage source, these two resistors, this voltage source, and this one. So we have in total 4 essential nodes. So just by simply counting the number of essential nodes, we realize that we need to have 3 simultaneous equations to be able to solve this circuit. Is there any other factors that can help us reduce the number of equations? The answer to that is yes. As you can see, we have this voltage source that is common between this reference node and this non-reference node. So that means that we can use even the concept of supernode to reduce the number of equations. So if we, for example, consider this to be the reference, this can be considered as the voltage source that is between the reference and the non-reference node, and we can use that to write a supernode equation. So based on the this basic analysis that we did, solving this circuit completely at most requires 3 simultaneous equations. So now let's just count the number of equations that is needed for us to be able to solve this circuit using the mesh current method. So how many meshes do we have in this circuit? We have one mesh here, another here, 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 and then finally here. So we have 5 meshes in this circuit. So if we wanted to go through the mesh current method, that means that we need to solve 5 simultaneous equations in order to be able to say we fully solved this circuit. So just by this basic comparison, we see that the preference for solving this circuit is with using the node voltage method. So let's just take a look at another one, another circuit. I will do the same for this one too. So let's just count the number of essential nodes. This one is not an essential node. It is the point of contact of 2 elements only. This one is the same. This one is an essential node. This one is also an essential node. This one is an essential node, and this one is also an essential node. So we have 4 essential nodes, which means that we need to write 3 simultaneous equations. What about the mesh current method? How many meshes do we have? We have 1 mesh here, the second one is here, and the third one is here. So we have 3 meshes in this circuit. So that is equal to having solved 3 simultaneous equations. So from the looks of it, it looks as if both node voltage and mesh current method are equally challenging. But is there any other factors that we can consider in order to simplify the calculations? So let's just take a look at these current sources. We have this current source that is common between the first mesh and the second mesh. We have this other current source that is common between the second mesh and the fourth mesh. Sorry, with the second mesh and the third mesh. So just by looking at these, we see that we can use the concept of super mesh to reduce the number of equations even further. So since this is the case now, the preference is with the mesh current method, because we can write the equation for this circuit by only doing one large super mesh. Of course, we need to have some constrained equations for these dependent current and voltage sources, right? But the whole point is that those are the things that you should even consider when you are using the node voltage method, right? But if you are using the mesh current method, you end up with fewer number of equations that you need to solve. So because of this, the preference is with the mesh current method. Of course, for some cases, the fact that what parameter we are actually trying to find also dictates which one is better or not. For example, let's just say if I ask you what is the voltage across this voltage source, for example. So that is a very basic example. You can easily see it is 193 volts, 193 volts, right? But if I ask you this question, do you even need to solve the circuit, right? So if you have a question, let's just say I have a resistor right here. So let's just say I have it as 10 ohm. And I ask you, what is the power that is being consumed by this 10 ohm? You might look at this circuit and get scared, right? Because the circuit seems very complex now. But just because I told you, okay, I'm looking for the power that is being consumed by this 10 ohm resistor, then it means that you don't have to calculate the whole circuit. The power that is consumed by this resistor, if you remember, we had a simple equation for that. It was the voltage across it, so the voltage of the 10 ohm resistor squared divided by the value of the 10 ohm resistor. So the 10 ohm resistor. So it would be 193 squared over 10, whatever this value is, right? So this was a very basic example for you to see that there are cases for which you don't even have to solve the whole circuit. So that's why I say, just by looking at the circuit without doing these basic analysis or without answering those basic questions, it is not easy to say which one of the two techniques, mesh current or node voltage, are better. But once you have the answer to those questions, then you can have a more informed decision on which one you choose to solve your circuit. So in this video, we try to answer the very important question of whether we need to use the node voltage method and the mesh current method. And to be able to answer this question, we need to have some answers for some follow-up questions that can help us better decide which one of these techniques to choose.